Now when we run the simulation, we're going to use risk general. Risk general is the continuous version of risk cumulative that we used in a previous example. So here X will be prior probabilities. So that's the potential true probabilities of birth defects going A22 to A121 for the uninformative prior and G22 to G121 for the informative prior. Both are the same. Okay, but the posterior probabilities for uninformative prior would be E22 to E121 and for and K22 to K121 for the informative prior. So we have two cases. Now we'll simulate that and we'll come up with from that simulated posterior probabilities. So we will take the 22.5th percentile for the lower side and 97.5 percentile for the upper side. So that will give us a band for each of these two cases for how many birth defects we will have, what is the proportion, and then we multiply that with the population size of 100,000. So that's what we're going to do. Let's head on over to Excel. Okay. So we'll set up uninformative prior here. So go to distribution, define, or you can do this from function, or you can just type out the formula. So here we have risk general. Okay. So we have a minimum. Minimum is 0 and maximum is 1, right? It's the probability. Now X table is that, right? And then Y table is this. Well, like that. Okay. So click OK. Okay, so that's our simulated probability. Okay, and for informative prior, again the same thing, but okay, 0 and 1 for minimum and maximum. Now X table is this, and the corresponding Y table is that. Okay, up to there, 121. Okay. All right. So once we have the simulated proportion, so this will be an output. And this will be an output. Okay. And then from here we can set up our low and high for these percentages. So we will have risk percentile. Okay. Of that. Okay, now we want to be able to copy this over here, so which means column B should be absolute reference, but when we copy this down here, that should change from 15 to 17. So absolute reference only for B, and then the low is here. Once again, we want to be able to copy across, which means the column should change from H to I, but when we copy this down here, the row should remain the same, so it's like that. So now we can copy that like that, and then copy both of them down here, and we need to put the thing back. So let's okay. Now here we need to take each low end and high end probability and multiply by 100,000. That should be absolute referenced. So that's the number of babies that will be affected. Okay, copy that over and copy it down here. Okay, so now we have set up the model. Now we can do the simulation. So let's make it enabled. I've been doing automatic and sometimes it doesn't kick in. So let's say 100,000. All right, and sampling is fixed at 1. Okay, so let's run the simulation. Okay, so here we have the uninformed prior probability, and we can now overlay that probability, and you see the informed so informative prior, and so informative prior is blue. Okay, let's change that to legend. So, and with uninformative prior, okay, you see that it overestimates the proportion of defective babies. All right, so now so it's around, this mean is around here, that one is higher, and uninformative prior has a larger variance as well, so it's much more broader than the width of the distribution is broader for uninformative prior. So let's compare these probabilities with the proportion, the prior proportion as the x-axis. So let's compare the prior knowledge. Prior knowledge would be without adding, without revising the probabilities to posterior, and then we will compare the uninformative the posterior with uninformative prior, and posterior with based on revised prior, informative prior. Okay, and then because we wanted the prior as it is with the informative case, right? All right, so highlighted those, and let's go ahead and print scatter plot. Okay, so let's move it here. Okay, let's select the plot, select data, and then let's change series 1 is E. So E is uninformative prior. All right. Series 2 is H. So H is informative. Well, let's call it just prior. Okay. Revised prior. So third one is column K. So that will be informative prior. That is posterior probability based on informative prior. Okay. And chart title is estimates of proportion of babies with Zika related side effects. Okay. Okay, so we can revise the x-axis. We don't want it to go all the way up to 1.2, so 1 is enough. All right. So then the axis titles are, this is the potential prior, well, let's call it just prior probability. Prior probability, and this is the posterior probability. Okay. So as you can see, so uninformative prior overestimates, which we already saw before. Informative prior is it's a lot more tighter distribution, which is good, and the mean moves closer to what we started out with. Okay, so if you look at the previous study, so when we revise the prior based on the previous study, the mean probability moves closer to the prior study. So and this is the revised priors, and this gives us using the Bayes analysis is when you use the information, the data that's available to make adjustments to the prior probability.